So welcome back. We're going to be on the home stretch of our foundations piece. This will be two more lessons counting this one. We're going to talk a little bit about area of triangles. So we're going to sprinkle in a little bit of geometry here. We've talked a little bit about a rectangle already. We know that a rectangle has this shape here. It's also called a quadrilateral, a four-sided figure. But in a rectangle, we know that these opposite sides are equal, and these opposite sides are also equal. When I want to find the area of a rectangle, what that means is how many squares are inside of it. So what we're asked to do is kind of cut this off into squares. So I got like 4 rows across this way. It's 4 rows high. It's like 8 rows across, or 8 squares across. So we have a drawing like that, and you can kind of see how hard it is to do this just freehanding it. But these are supposed to actually be squares of the same size. So the area is actually how many squares are inside there. And we learned that there's 4, 8, 12, 16, 20, 24, 28. There's 32 squares inside there. So we would say the area of this is 32 squares. But we also learned that instead of doing all that drawing, if you just multiply the length and width together, that will actually count how many squares are inside the rectangle. So there's a formula that says the area of a rectangle is equal to the length times the width. The length is usually denoted for the long side. The width is usually denoted for the shorter side in a rectangle. One thing to learn though, a triangle can be constructed by actually dividing the rectangle into two congruent triangles. So what we learned is, if I cut the triangle, or if I cut the rectangle in half, I'm left with a triangle, which means the area of this triangle should be half the area of a rectangle. So the area of this triangle should be, well, we said that was 32 for that. If I divide that by 2, 16 should be the area of the triangle. And 16 squares, or 16 square units, would be how we would denote the area. So when it comes to shapes like triangles and stuff, we kind of start to rely on formula, especially if you start throwing decimals and stuff in there. So what we learned is the area of a triangle, we actually use this concept of base times height. Half the base times the height. Or sometimes you may see it as base times the height divided by 2. Now, the base and the height are basically, base is usually what we call the bottom. The height is usually how tall it is. And notice that I could rotate this triangle around. If I spin it around, I could see this triangle look like this. So notice how, again, this would be the base, and this would be the height. So I can spin that around. Again, a synonym for height is also altitude. Just like you talk about the altitude of an airplane, the altitude of an airplane is how high it is off the ground. So those are synonyms. So they may not always use the word height. They may also use the word altitude. But the key thing is that height is a straight up and down distance, or what we also sometimes call is these two guys are said to be perpendicular. So perpendicular. Oops, that's just not too good there. Let me clean that up a little bit. So perpendicular, this is the symbol for perpendicular. Perpendicular kind of means you form that right angle there. So if it has that right angle there, that 9-degree angle, we say that those are perpendicular, straight up and down. Just like you talk about like a wall and a floor. A wall and a floor, you want those to be perpendicular because that's when they're the strongest. So let's look at a triangle here. So I have some dimensions. And notice that these sides here of the triangle, again there's 3 sides of a triangle. This side here would be considered the base or the bottom. And then the 4.5, notice how it's a perpendicular height? That's what we're looking for. So if I want to find the area of this triangle, I can use the formula, substitute the 8 in for the base, substitute the 4.5 in for the height, and I can divide that by 2. Now, one of the things we can also do here is notice that I can actually divide out, since this is like a fraction, I can actually divide out that 2 first. I can say 2 goes into 8 4 times. So really the only math I have to figure out now is 4 times 4.5. So 4.5 times 4. And remember, when you multiply, you treat it like whole numbers. So essentially, I'm just going to ignore the decimal and just say 4 times 5 is 20. Carry my 2. 4 times 4 is 16, plus 8, plus 2 is 18. And since there's one number behind the decimal, I slide it over and I get 18.0. So 18, and if I look at this, since this is using miles, I would say this is 18 square miles. Sometimes we write that as 18 square miles is written like that. So I also write this as 18 square miles like that, using the exponent. Number 2, again we have this strange looking triangle here that's kind of slanted off that way. And notice that we had to use some imaginary lines to kind of figure out what that height was. So notice how the base and the height are now perpendicular. Now my base is not this total distance. My base is just the length of the side of the triangle. So in my formula I have 4.7, well my base is actually 2, so 2 times 4.7, and I can divide that by 2. And notice that since this is a fraction concept, those 2's are actually going to divide out, so my area is actually going to be 4.7. And since we're using yards, we can say yards squared, or square yards. So 4.7 square yards is the most common way of saying that. Now this triangle here is a little bit different. Notice how this style line is going this way. But don't forget though, this triangle can actually be rotated around. I can spin it around and I can actually make the triangle look like this. It's still the same triangle. So at 12.1 is still here, and that 14 is still here. So it's 12.1 meters and 14 meters. So sometimes they may give you a triangle that kind of looks like this, but if you slide it around, you can kind of see that this is indeed the base, and this is indeed the height. Because we're used to seeing it like this. The base is the bottom, and then that height is the up and down distance. So sometimes they'll draw it where you actually may have to mentally rotate that around for yourself. So what I have then is my base is 14 times the height, which is 12.1, and I'm going to divide that by 2. Notice again, though, that 2 can actually go into that 14 first, and all I really got to do is do that 12.1 times 7. So when I do 12.1 times 7, I'm ignoring the decimal. 7 times 1 is 7. 7 times 2 is 14. Carry the 1. 7 times 1 is 7, plus the 1 is 8. Now I come back in and say, hey, there's one number behind the decimal, slide it over, 84.7. So the answer would be 84.7 square meters. So when you're dealing with area, you do want to put that unit in there. That's very, very important. Don't leave those units out. So area is measured using square units, so square meters. So on this one here, notice again how it's kind of drawn strange, but I can rotate that around where that long side is actually down at the bottom, and I have that drawing there. So this drawing can actually be spun around to make it look like that. So the base is still the 16 yards, and this height is, I think that 11, I got that, probably should be probably up here more, so the height is actually going to be that 11 yards right there. So the height is actually going to be 11 yards. So if it was down there, we really would have a little bit more work to do. And we're not at that level yet. So what I'm going to do is multiply the base times the height and divide by 2. So the area again is going to be 16 times 11. And we're going to divide that by, sorry, read that. So 16 times 11, and I'm going to divide that by 2. Notice again though that 2 does go into 16 8 times, all I really got to do is multiply 8 times 11, which would be 88. 7 would be 88 square yards. So I can use that notation. So there are some examples of finding the area of triangles. Stay tuned.